Up until this point, we've lived in fantasy land. Handout 9, all of those problems gave us the true mean, true standard deviation, the true proportion, and they asked us questions about the samples. Well, now we're going to start into real life, where we know nothing about the population, but we have to take what we know about the sample and try to guess something about the population. We talked about how, of course, one sample is better than one person, but we also talked that we don't know if our sample is really close, if it's a little bit above or a little bit below. So there has to be a better way, and that's called confidence intervals. We're going to be able to take our sample and actually build an interval of possible values. At this point, we will also be able to state our level of confidence, meaning normally we're 95% confident. That means, okay, 5% of the time we're going to be wrong. We have a general form of a confidence interval. We are going to be building 4 different ones over the next month. 2 of them are on test 3. We have the estimate plus or minus margin of error. If you have checked any of the political polls lately, at the bottom they should always give you the margin of error. We're going to talk more about political polls on Thursday because those are proportion problems. But today we're going to talk about confidence intervals for the mean, meaning we measured something. Well, margin of error is actually constructed by taking a z-score times the standard deviation. When we talk about being 95% confident, what that really means is that 95% of all of those samples, remember how we talked about that last time, all of the samples taken will end up building an interval that contains the truth. Mu, for example, would be the population truth, the population mean. 5% of them will not. Now, in real life, we still have no way of knowing if we had one of the good samples or if we had one of the bad ones, but at least now we can quantify how confident we are. I believe there is a nice picture in your book. So in chapter 7.1, they start to build the confidence interval for the population mean, for mu. So x bar is the estimate of mu, right? Z-score, standard deviation. Well, from what we talked about last time, the standard deviation of x bar is sigma over square root of n. So that's why we study sampling distributions. But here's the problem. We do not know what sigma is because that's the population standard deviation. All books will always talk about that, but I call that fantasy land. So really we're not going to use that formula. We're going to use the next one that I put in a box. Well, what could we use as an estimate for the population standard deviation? We could use the sample standard deviation, which is denoted by S, if you remember from test 1. Now there's this new thing called a t. You're not supposed to know what that is. For now, we're not going to get too much into the t distribution. I will tell you the t values are very similar to the z values. Before I keep talking about that, I want to point out that this formula is on your cheat sheet. If you look at your cheat sheet, under confidence interval for one mean, there is the formula. So you do not have to memorize that. All right, back to this t thing. Again, it's very similar to the z chart. It's unimodal and symmetric. Basically, t values are just a little bit bigger than z values. So if I'm plussing and minusing a bigger number, it's going to make my confidence interval just a little bit wider. See, when I use an estimate, the sample standard deviation as an estimate of the population standard deviation, I get a little bit nervous. And when I get nervous, for confidence intervals, it's kind of like I want to cover myself. I want to make the interval just a little bit wider so it will include a few more numbers, and that's what the t-value does. We are going to be getting t-values off of a special chart called the confidence interval chart. The only thing you really have to know is there's something called degrees of freedom. By formula, it's n-1. I'm pretty sure that's on your cheat sheet too. And then you have to know what level of confidence they're going to ask you for. I'm going to point out the confidence interval chart now to make sure everybody knows what I'm talking about. That is the confidence interval chart, and if you zoom in, you can see the confidence levels across the top, like 90, 95, 98, and then all the numbers on the left-hand column are called degrees of freedom, which is sample size -1, and then you will find whatever t value that you need. To have everything in your notes, I've also included exactly where you're going to go on your TI-83 for a shortcut. You're welcome to work these formulas out the long way, but I highly encourage you to learn the shortcuts on your calculator. So you'll go to Stat, Test, T-interval. You'll have to choose whether you have data. Did they give you a list of data that you had to put into L1? Then you'll pick that. Did they just give you the X bar and the S? If they did, then you'll pick the stats. On a test for me, always have to show the setup of the confidence interval also, not just the answer from your calculator. So let's do an example. Silly, made up, I kind of got this out of a book. Let's say we studied how many minutes of housework people do a day. We're going to look at moms, sons, and daughters. And we do know that minutes of housework is normally distributed. We have to know normality if we don't have a big enough sample size. And we're going to make what we call 95% confidence intervals for each. So there's the information. There is the mean of the 50 moms, how much they're spending on housework. There's the standard deviation, and the same thing for sons and daughters. Now, look at the mom setup. We have the X bar, plus or minus. Hold off a second on that 2.01. We have the 5 for the S, and then square root of n. Now, where did I get that 2.01 from? Well, degrees of freedom is n-1. 50 minus 1 is 49, right? So then I go to my confidence interval chart. You can't find 49. I just took the value between 40 and 60 under 95%. That's just to show the setup. Now